Hey guys, I hope you all are doing good. So this is going to be the final lecture about sets. In this lecture, we will be covering power sets, tuples, and then we will also understand what is a Cartesian product, right? So towards the end of the video, just like all the lectures, I'll be giving a bunch of questions for you guys to solve, and then I'll solve those questions towards the end, right? So let's start with what is a power set, right? So if you try to read the definition, a power set of a set A is a set of all the subsets of A, including the empty set and the set itself. We denote it using this symbol. So I don't know if you have covered a different denotion. This is what I covered in my university. So it's quite possible there could be a different denotion for it, right? But the basic idea stays the same. So power set is basically the set of all the possible subsets we can form for a set. So I'll try to explain it with a very simple example, right? Consider I have the set A. So I have A equal 1, 2, 3. So now in order to figure out what is the power set, which is 2 to the power A, right? We denote it using this symbol, and I'll explain what this basically means, right? I need to figure out what are all the possible combinations I can form over here, right? So I'm going to start with forming the very simplest combinations, which is going to be the individual element sets. So it could be 1, right? Set including 1, 2, 3, right? So I've formed a pair of individual sets and I have got 3 subsets over here. Now I can form pairs of 2. So 1 with 2, 1 with 3, and 2 with 3, right? So I get 1, 2. This is a subset. This is a possible subset, and this is also a possible subset. Finally, we also have to include the empty set and the set itself in the power set. So it's going to be the empty set and the set itself. And this entire set with 8 elements is going to be the power set for this specific set over here, right? Now, let's say it had 4 different elements, right? Then there would be multiple combinations. So you'll first have individual element sets, and then pairs of 2, then pairs of 3, and then in 4 there would be the entire set, right? So I hope that makes sense. Now, why do we denote it using this symbol? So the basic point is that the number of elements in the power set is going to be 2 to the power cardinality of the set. So if you look at it, this basically has 1, 2, 3 over 8 elements. So this has 8 elements, and if you try to understand it, A has 3 elements. If I do 2 to the power of 3, it's going to be 8, right? And that is exactly the number of elements we have. So this is a very important thing to understand. So consider you get a question where you have to find out the power set, right? So let's say I give you a question, find power set of B equal A, B, C, D, E. Now, in order to find the power set, it could be that if I just manually start doing it, I might miss a few elements, right? So that's going to be a mistake. What I can do is, first, I need to figure out the total number of elements that are going to be in the power set, right? So I see B has 5 elements. That means the power set of B is going to have 2 to the power of 5 elements, right? So this is going to be the exact number of elements in the power set. Now what I have to do is, I know the number of elements that the power set of B should have, and then I can figure out on my own what those elements should be, right? So there's just a very simple way. Start with individual pairs and then pairs of 2, 3, 4 until the entire set comes in it. And don't forget to add the empty set to it as well, right? So I hope you have a good understanding about the power set. Moving on, let's try to understand what is a tuple. By now, I hope you have a good understanding about sets. So I'll try to say the definition of what is a set once again, right? A set is a collection of objects where order and multiplicity don't matter. So the point is, I can arrange the elements in any way I want, and I can write the same element multiple times and it wouldn't matter, right? Now, according to the definition of a tuple, It is a collection of objects where order and multiplicity both matter. They are written using the parenthesis symbol. So just a very like important difference between the sets and tuples is we represent sets using this symbol, the curly braces, and we use tuples, we represent them using the parenthesis, right? So this is a very important difference to understand. Now let's try to understand the main difference between both of them. Now, in the case of tuples, order and multiplicity both matter. So let's try to understand this with an example, right? Let's say I have a tuple a equal 1, 2, 3. Now the point is that this tuple is not going to be equal to this tuple, and this is not going to be equal to 1, 2. The basic point is that if I arrange these elements in a different order, it is going to result in a different tuple. So all these three tuples are actually not equal to each other. But if this was a set, right? If this has curly braces, then all these three would have been the same thing. So the point is that order matters, and this is the example of how order matters, right? Same thing, if I have the set 1, sorry, the tuple 1, 2, 3, this would not be equal to 1, 1, 2, 3, or this would not be equal to 1, 2, 3, 3. So, and this would not be equal to, I can say 1, 2, 3. So I've just given two different examples. Now both combined don't really matter. So if you try to arrange the elements inside a tuple, that would result in a different tuple. And also if you write one single element multiple times, then they would be considered distinct elements inside the tuple, right? So the basic definition is, and the basic summarization is, that order and multiplicity both are going to matter, right? So that's a very clear difference between what is a set and what is a tuple, right? I think now that we have covered tuples, it would be a good time to introduce the Cartesian product, and I think you would be able to clearly understand how that works. Okay, now let's try to understand what is a Cartesian product, right? Try to read the definition over here. A cross B is equal to the set where there's a tuple AB such that A is an element of A. If you remember, this is the denotation of is element of, right? So A is an element of A and B is an element of B. Now, if you don't understand this definition, that's totally fine. I'll try to explain it with a very simple example once again. So consider that I have two sets, right? I have 1, 2, 3, and I need to do a cross product with A, B, C. The basic point of how a Cartesian product works is that I'm going to make a tuple of pairs for every single one of them. So what I'm going to do is I'm going to make a tuple of 1 with A, 1 with B, 1 with C. Same thing I'm going to do for 2 with A, 2 with B, 2 with C, and same thing with 3 once again. So 3 with every single one. So what I get is I basically get this set over here. So 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B, 2 comma C, 3 comma A, 3 comma B, and 3 comma C. So this is going to be the entire set. Now, very important thing to understand, if you feel like if you have missed any elements, just try to understand this, the number of elements in the resulting set, which is their Cartesian product, is going to be just the multiplication of the cardinality of the numbers. So the basic point is, if you look at it, I have 3 elements over here and 3 over here. If I multiply 3 by 3 is equal to 9. So the resulting set should have 9 different elements. And if you look at it, I have 9 elements, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the basic point is, if I do a Cartesian product, of this side with this side, you need to understand a very important part, right? If you look at it, I have a set and I have tuples inside it. Very important thing to understand is in sets, the order and multiplicity does not matter, right? But in tuples, the order and multiplicity matters. Now, this can be a very confusing thing to understand. My basic point is, let's say I have this entire set over here, right? The Cartesian product. My point is, I can write this tuple multiple times, right? Consider that all the other elements are still here. The basic point is, I can write this tuple multiple times because it is an element of this entire set, right? So it doesn't really matter. But the problem comes if I arrange the elements inside this tuple, that would result in a different tuple, and that would be incorrect. So if I write this 2 comma a as a comma 2 over here, this would be incorrect. You cannot write it this way, right? So you need to understand the basic difference. Inside a set, these tuples are all elements. So you can arrange them. I can move this tuple 3a over here. I can move this tuple 1c over here. Doesn't matter. But if I arrange these elements inside the tuple around, that would result in an entirely different set, right? Because that would be an entirely different element in itself. I hope that makes sense, right? So it's very important to understand the order in which we place the elements in Cartesian product. So if you try to understand it, I multiplied let this set with this set. Consider this is A and this is B, right? If you look at it, all the elements of A are on the left side, all the elements of B are on the right side. And if you look at this definition over here, when you do a Cartesian product of two different sets, it basically has tuples in it. It is basically a set of tuples where the left element is going to be the set which is on the left side of the equation, and the right side element is going to be the element which is on the right side of the set, right? So I hope that makes sense. Now, if I turn this around, so if I did this instead, so consider that I did A, B, C cross product with 1, 2, 3. This would result in A comma 1, A comma 2, A comma 3, and so on. So the arrangement of the tuples, the elements inside the tuple has changed in this case, right? So this is very important to understand. And now if you try to understand it, right, just like I said, in the set I can arrange the elements, but inside the tuple I cannot arrange them, right? That would result in a different tuple. So the basic point is that A cross B is not equal to B cross A in general, right? Because the tuples inside these two Cartesian products have a different arrangement. So I hope you have a good understanding about Cartesian product. Now I'll be giving a bunch of tough questions, right? And if I hope you guys are able to solve it, but I'll solve all the questions towards the end. Okay, so I hope you guys have solved all these questions by now. If not, let's try to start with solving question number 1. So given the set A equals, which contains the empty set and the set containing the element 1. Now it's very important to uh, have a very clear understanding about the set, right? So if you think about it, this is the entire set A, which contains two different elements, the empty set and the set containing the element 1, right? Don't confuse in these type of questions. This empty set, you have to consider it as an element of the set over here, right? So considering these as two distinct elements, the power set is going to be like this. So first, I'm going to form a subset of the empty set, which is going to be this, comma, I'm going to form a subset of this element over here. So basically, it's going to form two different brackets, right? So I have two different elements. Now what remains is this entire set itself, which is the empty set comma 1, and the last remaining element would be the empty set itself, right? So this is going to be the answer. The basic point is this empty set, which is considered inside this entire set, would be considered as an element, right? So yeah, don't confuse it when you see these type of questions, right? And since it has two elements, just like I said, the power set should have 2 to the power of 2, which is 4 different elements. So I've got 1, 2, 3, and 4 over here. So I hope you were able to understand this question. If you're not able to understand it, the basic point I would suggest is just think about it as two different elements. So let's say if this was A and this was A and this was B, this would simply be A comma B, and this would seem a lot more easier to solve now, right? Okay. Now let's try to solve question number 2. If set S has 4 elements, how many elements are in the power set of the power set of S? So this is another way we represent the power set, right? So in last video we covered this representation, and we can also represent it like this. So S has 4 elements. Now think about it, right? Power set is the power set of S is going to have 2 to the power of 4 elements, right? Which is equal to 16. The power set of the power set of S is going to have 2 to the power of 16 elements. I hope you were able to solve this question, right? So this is a pretty easy question once again. Now let's move on to question number 3 now. Let T equal the set which has the tuples xy such that x and y are elements of the set 1, 2, 3 and x plus y equals 4. Now we haven't covered this complicated set representation before, but I'll explain it in very simple words, right? So if you don't understand this type of definition, just try to read it a few times and it will start making sense. So the basic point is that this set basically has tuples, and these tuples which contains the elements x and y, and these x and y elements are elements from this set, right? So they can either be this xy can either be 1, 2 or 3, and we have been given another condition such that the x plus y should be equal to 4. So in very simple words, the point is the elements that we can use are 1, 2 and 3, and inside the tuple their addition should result in a 4. So the solution to this question would simply be the set 1 comma 3, 3 comma 1 and 2 comma 2. So this is going to be answer to this question. So if you think about it, I have xy, right? These are elements of this set. I am satisfying this condition, and x plus y is equal to 4. So all these conditions have been satisfied, and hence I get this set over here. Now, another question that I have is, why do you think 1, 3 and 3, 1 are distinct elements? So just like we covered in the lecture, right? In tuples, the order and multiplicity is very important, right? So over here, the arrangement of elements is different, and that's why these two are two distinct elements inside this entire set. Hope that makes sense. Moving on, let's try to solve question number 4. Given A equal 1, 2, B equal AB, and C equal the set containing the element A. List all the elements in A cross B bracket cross C and explain how it's different from A cross B cross C. Okay. Now, if you remember, when we covered the union and intersection, it was possible that I can do A union B first and then I can do a union with C. And I can do this part first in the union, or I can do this first. It would be the same thing, right? But that's not the case when it comes to Cartesian product. And I'll explain it with this question, right? So A cross B cross C, what this means is that I'm first supposed to solve this portion and then supposed to do a cross product or Cartesian product with this C over here. So what first happens is I need to find A cross B, which is equal to 1 comma 2 multiplied by A comma B. This results in the set 1 comma A, 1 comma B, 2 comma A, 2 comma B. Right? This is what it results in. And now what I'm supposed to do is I'm supposed to multiply this or do a Cartesian product of this over here with C. So I'm basically supposed to do comma A, 1 comma B, 2 comma A. Cartesian product with, I've got C over here. And this would basically result in this set. 1 comma A comma A, 1 comma B comma A, 2 comma A comma A, 2 comma B comma A. Now, if you look at it, this might seem very complicated, right? But the point over here is that I first solved it. There's already a tuple inside it, and then I'm combining it with this element over here, right? So when I do a Cartesian product of this with this over here, I need to consider these as distinct elements. I cannot add this A inside this tuple now. What I'm supposed to do is, since I've been specified that I need to solve A cross B first, so I form these tuples and then I'm doing a Cartesian product with A. So that's why I have inside this entire final tuple, I have a tuple of 1A first, and then I have the element A inside it. So element 1A with A, 1B with A, 2A with A, and 2B with A. But it's very important to understand that my tuple representation should be correct, right? There could be a small mistake that students can make, which is they miss these parentheses in the inside, and that could be wrong, right? So that would be incorrect answer to this question. So this is A cross B cross C. Now think about it, right? If I'm supposed to do A cross, I'm supposed to do B cross C first, and then I'm supposed to combine it with A. Then the point that will change is that I'll have to form the brackets over here. So I get something like this. So in the case of I'm supposed to do A cross B cross C first, it would be something like this, right? So I have so let's say I have, wait, I'll try to solve B cross C first, which is going to be A comma B multiplied by A. So I get A comma A and B comma A. Now I'm supposed to do a Cartesian product of this with A, right? But I need to understand that the A is on this side of the equation. So 1 comma 2 Cartesian product with A comma A, B comma A. And final answer that I get is would be tuple 1 inside another tuple again, A comma A, right? Again, then there would be 1 B comma A, tuple close, then 2, and then this way it would continue until the end, right? So the basic point over here is that this representation, which is 1 comma A comma A, this tuple over here is not equal to this tuple over here, which is, right, they are not equal to each other. So it's very important to understand this difference, right? If you're not able to understand it, try to watch this portion once again. But the basic point is that when it comes to the Cartesian product, right? I'll give a summary. I'll give a short summary of what I did. When I do a cross product of A cross B, I already formed the tuples. Now, those tuples that I formed will have to be used as specific elements. So the final product has a tuple, and inside that there's another tuple again, right? And when I change the order of the parenthesis covered, right? So when I'm supposed to do B cross C first, the parenthesis will be on these two elements, and in this case, they will cover the elements on the left side. So I hope that makes sense, right? Now, the basic point is that is why they're both different from each other, right? These tuples will be different from each other. So this Cartesian product, you need to understand, will be different. Now, let's move on to the last question. How many elements are in A cross B cross A, where the cardinality of A is 2 and cardinality of B is 3? So just like this is simply just math, right? So when I do multiplication, it's kind of like 2 multiplied by 3 multiplied by 2 once again. So 2 multiplied by 3 multiplied by 2, I get 12 elements. So I hope you were able to solve all these questions. If you were, that's pretty good. What I'll do is I'll also make a complete list of some very tough questions on the entire topic of sets, and I'll try to post a video on that as well, right? But now, for now, we will move on to functions from the next video. So I'll see you guys in the next video.